Hello everyone. My name is Tasneem. I'm the senior manager at 98 percentile in the HR department. And today we did a wonderful drive with XLR. It was amazing right from the very beginning, from the very first day when I got in touch with them till today. I think it was an extremely smooth journey with them. There were multiple follow-ups done by the representatives in order to check that we would be, what time we would be coming, how many people would be coming, what vehicle we would get. To that extent, they were so precise in giving all the information to us. It was extremely great to get associated with them and have a drive at XLR campus. So we are very, very happy that we got a chance to do this. Now, coming to the students, what XLR had, I think they were extremely enthusiastic. They were well prepared. They were aware of what they are coming for. I think there was some back-end preparation which they did that was commendable. They also were very confident and they were open to any kind of thing we were asking them to do. That was I think the best part. Now, I really hope we have a very, very fruitful association with each one of them and XLR in future. We are really looking forward to have many more drives like this.
Hi everyone, my name is Prachi Sharma and I'm the Senior Project Manager for IT Department at 90th percentile. So today we were here for this IT bootcamp, right, this technical drive and at XLR. So it was a great experience and I would feel that the students, they are the freshers, right, but it doesn't seem like that. So if I talk about their technical and cognitive ability, they all seems pretty good in that and that's what I felt. And I guess they have been taught pretty well at XLR, so that's how they have performed good in their aptitude and the technical tests. So I wish them all the best and it was a very great experience over here.
98th percentile. We visited XLR for the campus placement drive and it went very well today. Miss Ambika, Miss Pragati, everyone received us greatly here and we had a lot of enjoyable time here. The students even had great experience with us. They were interactive, they had good aptitude and all the technological skills they showed. I think they were all well and we really appreciate their time that they spared to us and I think we will be doing a great job. We are expecting a lot of people to be hired from them. Let's see. It was a great experience altogether.
Thank you.
Thank you so much.
From entering into this cyber tower to exiting out of this tower, the XLR team has been received me with such a care and pleasure.
I am the part of this XLR since 4 months. From the third month itself, they have conducted the placement sessions from the third month itself, and this is the fourth month, and this is the 90th percentile is one of the placement drive I have attended so far, and attending to this drive is such a good experience for me. All the HRs and the team made us feel very comfortable and confident.
XLR helped me a lot and I experienced a lot of things today. So I'm really hope to be I placed in that company. I'm confident about that. Thank you.
Hi everyone, good morning. So, Chandana, shall I start or you're waiting for others to join?
Yeah, we'll wait for like 3 more minutes.
Sorry,
10, 10.
10, 10. Okay.
Yeah, 10. We'll wait for 3 more minutes, okay?
Okay.
Still people are joining, right? That's right.
Shall I start now? Tell me. Tell me. Shall I start?
Yes, Naveen, you can.
Okay. So hi everyone. So today we will discuss the pending topic NoSQL. NoSQL database. Okay. So in NoSQL, there's a NoSQL family. Okay. And in NoSQL family, there are multiple families available, like document store is one family. The key value store is another family. Column-oriented column-oriented store is another family. Graph store. So our databases, RDBMS databases. RDBMS. So in RDBMS, we have Oracle, MySQL, DB2, Postgre. All these are NoSQL SQL databases. And these RDBMS databases, they store data in row manner, row oriented. So we define the table structure and then data is stored in rows and columns. So this is row oriented approach. Now in NoSQL engine, we store huge data, big data. So data retrieval and data insertion is fast in NoSQL. SQL is good for transaction capability. NoSQL is good used for analytical operations. And in arguments that used mainly for ACID, or you can say transaction capability. So here, the way we are persisting this data is slightly different from the row-oriented approach. So document store databases, the variety of databases that comes under this category. MongoDB is one example. Key-value store Cassandra, that is another NoSQL engine that store data in form of key-value pair. In column store, popular one is HBase, that is comes under column-oriented store. In graph, we have uh, Neo4j, and from the cloud, and we have Neptune DB from AWS, that is graph database. Okay, and along MongoDB, we have one more DynamoDB, that is also a cloud flavor. AWS provided this. So I'm targeting this category column oriented store, HBase. So in HBase, we store data, or not the HBase, the column oriented databases. On column oriented family, we store data in a column oriented manner. So Facebook, uh, we have HBase database behind the scenes. So, and what's the reason why we are storing data in column oriented manner? So that we'll understand once we have the architecture in place. So HBase architecture is inspired by Google. So Google has its own database, Bigtable. So we can put Bigtable in this category only. In column-oriented store, it's a Google database. Okay. So, but HBase is, you can say, it's a replica that created based on the Bigtable. So, Google provided Google file system. So in year 2003, 2006, so they have published some uh, white papers, and Google handle its own big data environment using both Google file system, MapReduce, and Bigtable. And now when they publish those white papers, so then basis on that, uh, in place of Google file system, this SDFS, Hadoop distributed file system was developed. MapReduce concept is now uh, referenced by Google white papers, and Hadoop MapReduce was developed. And big table, this is a NoSQL database. Basis on that, HBase was developed. These all are open source, and these are Google. You can say Google has its own set of ecosystem where we handle the huge data. Okay, so uh, Google file system is a storage. SDFS is also a storage. MapReduce is the processing engine, and Bigtable is a NoSQL database or a engine that is used for database management. Okay, so now, as I said, Google file system, in place of Google file system, we have HDFS for storage, MapReduce for processing, but on top of MapReduce, we have a Scoop, Hive, many more wrappers, but internally we have MapReduce only. And now, in place of Bigtable, we'll have HBase. So HBase and Hive. So if I create this is HDFS, Hadoop distributed file system. And on top of that, we have Hive, and we also have HBase. Hive is a analytical tool on top of HDFS. And HBase is a DBMS. HBase is a DBMS on top of HDFS. Could you please give list of NoSQL database system? I've also have written the list here, the popular one. This is what I discuss. MongoDB, DynamoDB, Cassandra, HBase, Bigtable, Neo4j, Neptune. There are many more. There are 200 plus. So we worked on specific families only. One or two databases we used in our whole career. You need to understand these categories only. Um, so if you understand this concept, so now in place of MongoDB, if someone provided you DynamoDB, it works on the same principle. So you can easily work on DynamoDB or MongoDB or any other database in this category. Same case with HBase. If you understand column-oriented approach, then you can work on HBase, Bigtable, and others. And if you want to see the list, then go there. NoSQL databases, you can find the list. CouchDB, AstraDB, DynamoDB, MongoDB, Redis, Astra, Raven. There's a huge list. But how you categorize all this? You can categorize on this category. So if I'm okay, Qbol. Now we want to check, okay, Qbol is fall under which category? And if you worked on this family, then you can work on Qbol. Let's say Qbol falls under column oriented. So then you can easily understand the database. Okay. So now I'm covering column oriented. It's not possible to cover the entire radar in one go. Just understand one or two, and these are popular ones. Document oriented, column oriented are the two one majorly used. So now, as I said, it's a wrapper on top of HDFS. Hive is a wrapper on top of HDFS. HBase is a wrapper on top of HDFS. HBase is used for ad hoc query operations. And this is for this Hive is used for batch queries or batch operations. So let's say business is asking some report, some quarter report or some fixed report. And on Power BI and Tableau, we create those BI reports. So that batch query will be run on this HDFS data. But ad hoc query means we are firing, we are giving a customer support, and those customer executives is firing multiple queries on the on HDFS. So that HBase is used for that purpose. Okay, so let's see more. So um, so HDFS and MapReduce combines as we call it as Hadoop. Okay, so we already discussed it's a distributed framework or a tool developed by Apache, and it's written in Java. So HDFS is a file system to store the data. MapReduce is a processing engine on top of that. So if we go further, so we knew that we have name nodes and data node. Name node is the master node, and data nodes. So data is stored in a partition manner on these data nodes. So if we have this large file, so it will create a block on this file. And this file is broken into a block size of 128 MB. This is what I explained on day one. So these blocks of 128 MB size is stored. We are calling these blocks as partitions across the data nodes. So as we can see on the data nodes, these are distributed, and name node store the metadata information of these blocks. Okay, so this is how this metadata information is stored in a name node. So file name, the block name, and on which data node. Okay, so now metadata is stored on the master node, blocks is stored on the data nodes. And if one block is corrupted, so that node is crashed. Okay, so that's why we define a replication factor. One block for one data node. Block means your partition. If you are storing data in a distributed system, if you are storing data in a distributed system, you need partitions. And those we are calling these partitions as blocks. And block size is of 128 MB. So here we can see this data file, this large file is divided into blocks, and block size is 128 MB. Now, if we have 8 blocks and our HDFS cluster contains 4 data nodes, so it distribute these blocks or partition equally on the data nodes. That's how we store big data. That's how we store data in a distributed system. And the metadata information related to this is stored on the name node. That's the whole concept of a distributed system. It's not about HDFS, whether you are storing data in a NoSQL database, you are storing data in a data warehouse or in a data lake or in any distributed system. This is the concept. How many blocks store in one data node? That also I explained based on the CPU. If I CPU size, you can store not CPU, the hard disk size, because data is stored in disk. So if disk is 2 GB, so now you can calculate how much data we can store on a single node. So this is how so now if data is corrupted on one data node, so we have a replication factor, we can recover that data from other node, because blocks are replicated on the data node. Okay. So this we already discussed. MapReduce, that it process the data, it reads the data, store the data. Okay. So let's go to the HDFS, where is HBase? Okay. Now discuss on HBase. SDFS, MapReduce, we already discussed. Now, as I said, HBase is a database management system. It's a DBMS system on top of HBase, on top of SDFS. So, uh, let's say, let's one example. So, these are the various limitations we have for Hadoop. So, unstructured data, okay. So that is one problem. No random access. Random access, if you want to fire multiple queries on the SDFS, it's not possible to retrieve data. So if we are using that SDFS data for customer support operations, so that's not feasible. And high latency, our job is running for long hours. No asset compliant means we're not able to update or delete or do any transaction management on SDFS data because it's not a transactional database. So these are the problems we have in HDFS when we dump our data in HDFS or in Hadoop. Okay. So let's discuss one by one this unstructured data. So data is SDFS is unstructured. So in databases, we have schema, but in SDFS we don't have any schema. Okay. So here we dump data in form of files, text file, logs, whatever format the raw data have, we just dump the data in HDFS. Okay. So there's no concept of row and columns and no tables, nothing. So we can store structured data in the same manner in CSV form, in Excel form. So that is one limitation. No random access means in databases, we just query the query, we can create the data, we can retrieve the data, we can update the data of individual rows. This is not possible with Hadoop. And it's optimal means it is used to store large file. Okay. And if you want to process those files or read files, MapReduce is the only option. Okay. So there is no provision to access or modify the data. That's the problem. Random access is the problem. Latency, uh, inserting or updating or deleting data should be fast, but it's not possible with this large data set because SDFS store data in a large files. So now this is also high latency is the problem. And last one, asset compliant. So it is asset compliant means uh, perform update, deletes, or you can perform transactions. That's not possible in HDFS. So in order to overcome these problems, let's go. So all these limitation makes Hadoop unsuited for transaction. That's a very important point. Because of these limitations, we not use Hadoop for transaction processing. But HBase solve all these limitations. It's the distributed database management system that sits on top of HDFS and try to overcome all these limitations of HDFS. So HBase, so in Hive, as I said, in Hive, store its data in HDFS only. In a similar manner, HBase store data in SDFS only. Because HBase or Hive, both are wrapper tools on top of SDFS. One is solving the problem of analytical queries or batch queries. Another one is solving these problems that I highlighted. Which latency is good, high or low? You tell what is latency. What do you understand by latency? Means the job performance. If you are retrieving or if you are performing any operation and it takes time, that is latency. So latency should be good. Latency should be high or low. Yeah, it's a delay. So if I'm finding a select star from table name query, let's say a high query, and we have 10,000 records and our query is running for more than 30 minutes. So is that good or bad? Latency is high or low? Latency is high. Latency latency is high, so we need to optimize. We have to optimize that latency and try to reduce the latency as much as we can. So latency should be low. So that's why this whole ecosystem or these sort of tools are developed. Otherwise, why there's a need of Hive or HBase or Scoop? Why we are using these tools? These tools are providing the optimization on top of HDFS, and optimization just reduce the latency. Otherwise, if we use HDFS directly, let's say we are retrieving data from MapReduce directly. We knew that MapReduce in the engine that retrieve the data. So your operation will, your job is run for long hours. You have to wait. So that's why this in the Hadoop ecosystem, these tools are developed. Okay. So now solve this problem using HBase. Okay. So HBase, now HBase solve this problem. So it uh, whenever we run any query or when we perform any operation on HDFS data, we will have low latency if we use HBase. We can randomly access, we can fire multiple queries on HDFS. Okay. Assets, so it provides transaction management also. And HBase also has the awareness of the structure of the data. So HBase solved all these problems. But again, data storage is still there. We are doing operations via HBase, not directly on HDFS. So HBase is a wrapper. It's an engine on top of this. Data is still here. It just we are doing those manipulations or doing retrieval or ingestion or whatever we are doing through HBase only. So now see uh, how we create table in HBase. So let's see the cluster. HBase has, as I said, it has master and slave node. So in HDFS, we have master slave, we have name node, data node. In a similar manner, in HBase, we have a master node. We are calling master node as master only. And there is a region server. Data node, we call data node as region server. We can have multiple region server. It's also a distributed system. Okay. So now start HBase shell. Start HBase shell. Just like Hive, just restart HBase shell and we can create our tables. We can do create, read, update, delete. But HBase uh, commands are slightly different from SQL. So here in HBase, so let's say create command we have in SQL for creating our table. So here also we'll use create. Then select command is for read, but in HBase we have get. For we have insert in SQL. Here we have put command for select all. In select star, we have scan. Okay, scan available. For delete, here also we have delete. And then update, here we have update. But in HBase, there is no update. Just we do update, but using put command only. Okay, so let's see these operations. So these are SQL operations, and here we will have HBase. So let's see. So HBase shell is started. So this is how we create uh, table in HBase. So create table name, and here we need to define our column families. One column family is mandatory. Okay, so column family contains column. So in one single column family, we can put all the columns data, but we can create multiple column families also. So let's say in a table we have 4 columns, so we can store 2 columns in one column family, 2 columns in another column family. So create this table. So create table name. Personal data is a column family 1. Professional data is column family 2. So table is created. Now describe. So first we can check the table using list command. So we can see there are 2 tables here, employee and employee 1. Now describe. So it describe that it has a personal data column family, and these are the various properties that internally uh, these properties are enabled on our table. So 1 or 2 properties are important. So this versioning is whatever operation we are performing on this table, so it maintains the version. So let's say today I'm executing one query, we are inserting data, and then we are updating that data uh, multiple times. So it keeps the copy, and we can run the past queries, TTL queries. Means let's say today is um, 15th and we want to check the data for 10th of December. So it has that version copy available. We can go back also. Okay, it's kind of a backfill operation. So, and also uh, it added a timestamp column. So when we are inserting the data, with every row, a timestamp is added, and uh, okay, and you can see TTL. The TTL is based on the versioning. Right now, there's no compression, but we'll enable compression as well. So these are few properties that is enabled by default. So now insert some data. As I said, to insert data, we use put operation. So use this put table name. This is row 1, row ID, row key. Personal data is the column family. Column name is name and value. So first row is inserted. Then insert second row. So again, table name, row key 1, row ID, column family, column name is city, and Hyderabad. Now, in a similar manner, insert next. Oh, okay, another record is inserted. Okay, so now you can write a select star from table name. So here we have scan table name. So we can see this data, and this, as I said, timestamp column is auto inserted. So we have city values this name value this, salary value this. So let me show you. Let's say this is my data, or this is my table in our database in a RDBMS system, and we have these columns. Now transpose this. So this uh, in HBase, data is stored in form of row and column, key value pair. So values your data and key contains your row ID and column ID. So let me explain. So key is 2 and your column ID is for user and value is chance. This is how it's stored. So see, this is row oriented database. Transpose this, convert row into column, column into row. So you see here the column type for user and its value is this. This is column oriented approach. This is how HBase store its data, or any column oriented database store its data. So the advantage is, let's say, uh, Rayan, uh, there is no type available for Rayan. So we will not store that particular, you can say, column information. Here we have a null value created. So it unnecessarily utilizes the memory. But here, whatever information available now in this diagram, as we can see, for Rayan, 4 columns information are available. For Chaz, 4 column information. And for Rick, 3 column information is available. So we keep 3 column information only, not 4. But in case of this kind of system, we need to keep all the information. I hope you guys understand what I'm trying to explain. Okay. So that is row and column approach. That is, so when we have, uh, let's say, in a recommend, when we are designing a recommendation system, so there we have, in case of Facebook, social media, so we have likes, comment, post. So that data is generated very fast, and also some, not every user do a comment. So the user that doing the comment store that information. If another user is not doing that, no, don't store that information. So that is possible in column oriented store. Row oriented is not good for that kind of scenarios. Uh, yes, I will share after this session. So as we can see here, this value is inserted. Now we can retrieve. So get, using get command, row ID 1. Um, so see, it retrieve the information. Okay. So, um, but if you are not good uh, in HBase, you have to learn all these commands. These are HBase commands, and you are familiar with SQL. So if you want to run SQL, if you want to run SQL on HBase, that is also possible, but it add latency. So there's a tool, Apache Phoenix. So this tool is a SQL engine on top of HBase. So in some organization, what they did, they have added one more server. Uh, so we have HDFS. Then on top of that, we have HBase. Then on top of that, we have Phoenix. And on top of that, we have Phoenix client. So Phoenix client, then this is Phoenix server, then HBase server, then HDFS server. So and below we know that HDFS store its information. Okay. So this is a SQL interface. This provides a SQL interface. Okay. Now here we are running our HBase command. Then those HBase command interacts with HDFS commands, we can say, or HDFS language. So we can run those SQL queries that we have learned through RDBMS using this kind of interface, but still it's adding multiple layers, or and your SQL query converted into HBase, then HBase connects with HDFS, so then it will pull out the result. So it's add little bit of latency, but it solve that problem that you don't need to learn those HBase operations. Uh, you can work on using SQL. And to interact with HBase, so there's the official documentation. So here we can interact HBase using APIs as well. The REST API. Here we can see these are get, put, post, delete API. So if we hit, let's say, let's create one, get, put. Yeah. So using these commands, we can communicate with the HBase server using these REST API. So it exposes REST API as well. So it's a get command. So it's fetching the data of all users from all regions. Okay. Here we are fetching uh, information from user table that contains this the row ID. Okay. So that you guys can study. This is the official documentation. So as I said, it's a transpose of the data. So row data is stored in the form of columns. Okay. And it's a sorted map wherein we have the row ID, the column family, the columns, and the value is stored along with the timestamp that is automatically added with the data. So, so when we read the data using get command, so it perform a lookup based on the row ID. So based on the row ID, it fetch that map that is stored in the HBase. So as I said, region server is the data node. It's kind of a data node. So it's stored, it has regions, and a servers have multiple regions, and regions are nothing. These are just the row groups. So row ID 1 to 4 is stored in one region, 5 to 8 in one region, 9 to 12 in another region. So these row IDs are divided into row groups, or you can say the ranges that are stored within a region. What is the use of HBase command if we have Phoenix? Oh, if there is no H Phoenix, as I said, so why we have HBase if there is no SDFS? Why we are learning all this? If there is no HBase SDFS available, then what is the use of HBase then? What is the use of Hive then? HBase, not saying we are doing data is here in HDFS. HBase communicates with HDFS. Phoenix doesn't directly communicate with HDFS. No, HBase communicates with HDFS only. And HBase is developed in a different language. And that language we are not comfortable. That's why we are installing Phoenix. Phoenix talks to HBase. So we will fire SQL query. That SQL query interacts with HBase using, and that query with converted into HBase, they have their integration in place. Now HBase communicates with HDFS. HBase communicates with HDFS, and then it pull out the results. So there's no direct integration. This is how they communicate. And as I said, there's no use for Phoenix, just leave it. Learn HBase and perform the operations. It just I said these kind of things are also available. And it's not very common that every organization uses Phoenix. Okay. So yeah, so region server contains region, and region are just the groups only. Okay. So yeah, that's it for this. I will share these documents so you guys can start the HBase server that is pre-installed in HBase, and we can learn these HBase queries or commands. So the external users, they connect HBase using APIs. There are multiple ways to connect. We can admin people, they directly they have the server control, so they can communicate in this manner. We can connect with HBase using the Java Python codes. Let me show you. See, this is the code, Java code. So here, what we are doing, we are passing that we need to create a table. Here we are passing the column family names. And then if I execute this code, Java code, so it will create a table in HBase. So it's equivalent to the command that I have created, that I have executed on this command. This command on HBase shell is equivalent to this code, this Java code. So this Java code connects with HBase, and then it executes these commands internally. There are multiple ways to interact with the HBase. Okay, so Chandana, you can start the test. I'm done from my end. So I will share all the materials if something is missed, but this is what we studied in the 2 week session, and and we are working on the same set of tools in industry also. So you just need to go in deep that how these tools are interrelated, what is the purpose, and language wise, yes, Python, SQL, these are the primary languages we have for uh, this field.
Okay, Naveen. Thank you. Uh, Guys, now we have a surprise test. So we'll start at 11 o'clock. Okay, 50 minutes time is there. So I'll send that Google form. So 50 MCQ, we have 100 marks. Okay, I'm sending the test. Please take your test. Okay. And attendance link, I'll send last 10 minutes. So I sent the assessment link. So please start your test. Okay. There's 5 more minutes is there, so be finished before 11:50. So I'm done of the access. Okay. Guys, 11:50. I'm going to share the attendance link and give me a few more minutes. So I'll show toppers as well. Okay. Yes, I hope you mark your attendance. Guys, 11:50 I close the access for the test, so you can't able to submit. Okay, now I'm sharing the top 10 list, okay? So this is our top 10 list. Congratulations who are all in the top list. And guys, is there any queries regarding certificate and all? Please let me know. I will answer the questions. And within 7 working days, your certificates will be given via your email. Okay. And if you have any queries like you didn't get certificate or you have to know your attendance, so please drop an email to edel@excello.com. So my team will connect with you. So I'm sending that mail ID in the chat box. Please take from the chat. Okay, is there any queries? Please let me know in the chat box. Swarna, what you're asking, I didn't get you. Is it available in XLR website, ma'am? What you're asking? So from YouTube, Chandra Reddy, yeah, like 11:50, I turn off the access so you can't able to submit the test. No, no, no. Certificates we are sending via through your emails. Whatever you registered to this LMS, uh, for that emails only you will get certificate. Reshma ma'am, you will get that notes and PPTs in the LMS, okay? We will upload there. After the session, I upload in the LMS. So LMS is a learning management portal. It's Excel's e-learning portal. Okay, if you have any queries, please drop an email to edl@excello.com. Regarding score as well. Okay, I hope there is no more questions. Okay, it's good to go, Naveen. We'll wind up the session. Naveen, are you there? Okay.
Yeah, hi. Hi, Chandan.
Yeah, it's good to go. We'll wind up the session. Okay.
Okay, sure, sure. Thanks.
Yeah.
Bye.
Yeah, bye. Okay. Sir, I gave access for unmute yourself so you can talk now.
Yeah, a formal valedictory, ma'am. This is Rajesh Kumar. I thank you, the team from XLR organization, for organizing this FDP sessions in a disciplined manner. And the quality of the resource person, what we have received from multiple sources, is really excellent. So I thank you, Navin Kumar sir, for a special thanks on my behalf of our department and our organization. I thank you all the participants for actively participating in the sessions. Thank you one and all. Thank you.
Yeah, thank you, sir. Thank you so much.
Okay, ma'am. So can we wind up?
Yeah, we'll wind up it.
Sure. Thank you.
Yes, certificates you will get within 7 working days through your emails. Okay. Okay, we'll wind up the session and we'll meet on next program. Up to then, take care. Have a great day. Bye bye.